All right, Chemistry CP on Friday, January 8th, 2021, nomenclature for covalent molecules. A covalent molecule is one that shares electrons. Oh, how nice. And if it's sharing, that means right off the bat, there aren't any metals involved. The metals are the 2/3 left side of the periodic table, and they are only bonding by giving electrons. That's an ionic bond. Non-metals crowded into the right third of the periodic table, upper third corner, they're so lonely for electrons, all of them, that they're willing to share their loneliness with each other. Again, ionic means taking and giving electrons. Covalent means sharing is caring. Things you may have recognized from your everyday world. CO2 is called carbon dioxide. CO is called carbon monoxide. You probably don't know this one. Nitrogen trichloride. And here's dichlorine heptaoxide. Haha! You are to learn how to name these things and write these things from their names. Note the di in carbon dioxide distinguishes it from the mono in carbon monoxide. Note that the tri in chloride tells us that there's 3 chlorines. Di again means 2. Hepta is the Greek word that means 7. We're using the same words or prefixes of words from geometry. You might remember that a 3-sided polygon is called a triangle. What do they call a 4-sided polygon? It's kind of rhetorical because we're about to see the answer. If it's just one element, we would use the prefix mono. 2 is di. 3 is tri, as in triangle. And 4, a 4-sided polygon, is called a tetragon. At least 4 elements in a molecule, we're going to call it a tetra. 5 is penta, pentagon. 6 is hexa. And I'm sorry I didn't pause, but I really want to get to the rest of this PowerPoint. I should back up and say, look, write this down fast. Here's the rest of the list. 6 means hexa. 7 means hepta. 8 is octa. 9, nona. 10, deca. Write that down. All right, so now we're going to use these. Here we go. We use them to say how many of each atom that we're using. For example, S2O3. Oh man, I've gone through my entire list of students, have I? Well then, vanity, name this molecule. Okay, so the way this works is there's no metals involved. Both sulfur and oxygen are non-metals in the upper right third of the periodic table. And this entire PowerPoint is staying in that region of the periodic table. So the rules that we're going to be using here are just to say oh man, maybe I should turn on some highlighting, is to say, what is the subscript for the sulfur? The answer is 2. What is the prefix that means 2? It is di. What is the subscript for the oxygen? It is 3. What is the Greek prefix that means 3? It is tri. So this name becomes disulfur trioxide. Ta-da! Di means 2, 2 sulfurs. Tri means 3, 3 oxygens. And no, this isn't a sulfate. It's not a polyatomic group. It's 2 lonely non-metals choosing to share electrons. Here's another one. What is the Greek word that means three? Why, that would be tri. And what is the Greek word that means four, Amber? The the second molecule still has its ending changed to IDE. So yes, this becomes tribromine tetrasulfide. Here's another one. Name this. Almost. So the first word, like bromine here, doesn't change to an ide. It's only the last one, and it's only when it's an element, not a polyatomic ion, where the ending changes to IDE. So this one becomes dinitrogen pentachloride. Ooh, another one. Name this molecule. All right, so this one is indeed called tetrasulfur monoxide. When the second element is just one, we would go ahead and use the prefix that means one, in other words, mono. But when the first element is just one, we do not bother using the word mono, the prefix. Oh man, name this molecule. Excellent. Although this is commonly known as water, its chemical name is dihydrogen monoxide. Name this molecule. Well, sulfur dioxide. We don't have the mono for the leading element if it's just one of them. Ooh, how would you write the formula for this one? F subscript 3, O. Ooh, pentacarbon decaoxide. C5O10 is correct. And there was two more slides, well, one full slide to go. So we got close to the end.